This is Talking Ears. I'm Juan Vasquez.
And I'm Frank Wardinger. So excited to be here.
Likewise. This time around, we're going to be reintroducing a former guest of ours on Talking Ears, Dr. Colleen Prell.
This is the continuation of our episode series covering the 2025 National Hearing Conservation Association Conference.
In Colleen's contribution to the Updates in Music Audiology workshop, she talks about some data and research when it comes to hearing protection devices, particularly with ensuring and verifying that the devices are actually doing what they're intended for. So it's really nice to get this background information and all this scientific research that goes into part of what we do.
Colleen's talk had the distinction of being the most graphically rich presentation of the day, so we have taken a little bit of liberty to edit around when she is pointing out visuals that we are not able to see, as this is a audio-only format with the podcast.
Dr. Prell is former past president of NHCA and is very well accomplished and has a decorated resume when it comes to her contributions in hearing loss prevention.
We've put Colleen's longer bio into the episode description, so please take a look at that. Her talk actually wraps together a bunch of different studies, some of which were previewed last year by our interviews with the student award recipients at the NHCA conference. So without further preamble, here is Colleen Prell.
I'm going to talk about hearing protection, in particular, the products that are very often marketed as musicians' hearing protection or uniform fit hearing protection. We know that engineering and administrative controls are your best strategies for protecting people's hearing. The reality is that hearing protection devices are much more often going to be used than getting the sound levels turned down. Maybe the World Health Organization documents will start bringing levels down eventually, but in the meantime, we're looking at HPDs. NHCA has a position statement for recreational music exposure that recommends uniform fit hearing protection products for those, concert goers, club goers. In-ear monitors with education on safe listening, are recommended for musicians, or custom HPDs. These uniform fit, custom fit HPDs are recommended in a AAA document, clinical consensus document, which Michael led the development of, and a number of people in the room right now were contributors to that. So I wanted to share with you what some of the best practices are that came out of that AAA 2020 document. One of the major things in that consensus document is that it is not adequate to just perform impressions. The hearing test, the education, the counseling are really, really important. And another part of the total body of care that is absolutely critical is verification of the product performance. So as we're talking about earplugs, making sure that the person is able to put them in correctly and get the attenuation that you are hoping that they will get by providing them with that product. So training on the insertion, verification of attenuation are really essential. There's some recommendations for how you can do the verification, measuring the attenuation at 250 hertz to verify the seal is recommended. Measuring the difference in attenuation between 250 hertz and 4,000 hertz is recommended as a measure of uniformity. The larger that difference, the less uniform the attenuation of the earplug is. That comes directly from Corey Portnoff's work, Portnoff and Price. Some of the considerations in selecting a product, the labeled attenuation is one of the things that gets looked at. We've talked about, 9 dB and 15 dB filters you heard just recently. The labeled attenuation is going to give you some idea of the attenuation that most users can get when the product is well fit. That's based on laboratory data, and individual achieved attenuation is highly variable relative to what is on the packaging. That's why a verification of how much attenuation someone gets and reproduces is so important. Over-attenuation is going to prevent the user from hearing things they want to hear. As you just heard, this is optional People aren't wearing these products because somebody is telling them they have to do it as part of their occupational safety program. They're choosing to do this. So over-attenuation will be a factor in, lack of use. Under-attenuation is also a problem because it leaves somebody at risk for hearing loss. It's one of the nice things about DB Check is giving people both the OSHA and the NIH guidance so they can see where they are relative to both sets of those recommendations. So how much attenuation is a key consideration, and then the uniformity of the attenuation. The AAA consensus document has two recommendations. One is provide the minimum amount of attenuation necessary so that you're not getting into an over-attenuation range and having somebody choose not to wear it. The earplug that brings them down to 85 dB or it brings them down to 90 dB might be one that they're not willing to wear. So over-attenuation is a real concern. It also recommends the most uniform attenuation possible in order to have the least distortion. So the idea is it will sound better if the attenuation is flatter or more uniform. And so we've done several studies in my lab, and I'm going to share some of that data with you because we've really been trying to generate the evidence that would lend more support to these recommendations about amount of attenuation and uniformity of attenuation, and give clinicians more confidence in being able to say, this is what the data show, this really is going to give you the best quality. So the first study, some of you might recognize Tess Sicardi. She was a student in my lab. She was presented this data at NHCA a few years ago. This was a study where we used 9 earplugs, and participants came into the lab. They were mostly AUD students, so presumably they knew something about putting devices into their ears. So we thought this would be like a really best case scenario. You're taking people who know how to put things in their ear and having them use the earplugs. And we measured how much attenuation they achieved when they put the earplugs in and how uniform the attenuation was when they put the earplugs in. 5 of the participants completed testing with all 9 of the products. The other participants each had, 1 or more. A number of those other participants had 5 or 6 conditions they participated in. And then they also did sound quality measurements. So after we measured attenuation and uniformity, they would listen to a particular song. It was by Portugal the Man. And they would rate the sound quality. So they rated the bass, the clarity, the overall quality of the music with nothing in their ears and with the different earplugs inserted. And we were expecting that, the least attenuation and the most uniform attenuation would be associated with higher sound quality ratings, was the hypothesis that we were testing. If you look at the data on the packaging, and again, that's not what real users, what every user achieves, but I wanted to give you some sense of what these earplugs look like from the laboratory data. So on the product packaging, in addition to the NRR, you have the attenuation that was achieved at individual frequencies. So what I'm showing you here is the manufacturer's data on overall attenuation with the NRR, and then the uniformity of attenuation. So you can see that some of these earplugs had very little overall attenuation. Others had more overall attenuation. And the uniformity was different. 0 means there's no difference in attenuation at 250 hertz and 4 kilohertz. The further off of that horizontal dotted line you get, the greater difference there is between 250 and 4 kilohertz, so the more sloping the attenuation would be. Now, as you can see, we did not see any reliable differences in the music quality ratings with these 9 different earplugs. Within individual users, some of them had big differences in liking one more than another. You can see the error bars are fairly large. But there were no group differences where one earplug was clearly perceived as sounding better by all of the participants in the study. But as I've just said, not every person is going to get the labeled attenuation. So maybe there are differences in either the overall attenuation or the uniformity of attenuation, which we're not seeing, because the individual achieved attenuation is confounding that. So these are the individual participants' data for each of the different earplugs. And you can see that some of them, people were pretty consistent in getting data that generally parallel or look like what the manufacturer collected in laboratory settings. In other cases, the individual attenuation achieved by the study participants was all over the map and was, almost always lower than what was on the product labeling and was really variable from person to person. So what we did is, rather than continue looking at everything based on the manufacturer labeling, we started using the individual data for achieved attenuation and achieved uniformity to try and understand how that might interact with the quality ratings. So here, what I'm showing you is a personal attenuation rating that we used to get an overall attenuation measure for the study participants. So NRR is essentially calculated as a weighted average, all of the frequencies from 125 hertz to 8 kilohertz, with less weighting of 3, 4, 6, and 8 kilohertz in that overall formula. And then what they do with the NRR, they take the group level data for the attenuation at all of those frequencies and calculate the average attenuation and the standard deviation for the group. And then they subtract 2 standard deviations from the mean and then subtract another 3 dB for spectral variation, because the noise environment that somebody is using the earplugs in could be different, probably is different, almost certainly is different than the noise environment that they're measuring NRR with. So that's also how you get a negative NRR, is you have your mean, and then if the mean is a relatively low value, you subtract 2 standard deviations and then another 3 dB, and you start getting into those negative numbers. So what we did in the lab is we took the attenuation data at those individual frequencies, and we calculated a personal attenuation rating by weighting those frequencies in the same way as is done for the NRR. When you do that, what you see is that, again, some of the earplugs, people did a really good job in getting the anticipated protection based on that labeling, the NRR labeling. In other cases, they were nowhere near getting what you would have anticipated they might get based on the product labeling. So as we move ahead, I'm going to use this personal attenuation rating as a measure of overall achieved attenuation. And then we also have uniformity. So what I'm showing you here, these are linear regressions. We needed a way to standardize, is something flat or not flat. So a linear regression essentially is a statistical way of saying, is there a change in one value as a function of something else that's changing? So we're using frequency and attenuation at those frequencies. And so what we're asking is there a reliable change in attenuation as you look across frequencies? And so the black lines, that statistical test was negative. We were not able to say there is a change in attenuation as frequency changes. So those are what we're calling flat earplugs, flat achieved attenuation. The red lines, there was a statistically significant change in attenuation as a function of frequency. So as you're going from 250 hertz to 4 kilohertz, there is a reliable increase in attenuation. So those are the sloped measurements. And so you can see some of them generally tend to be relatively flat for most users. Some of them generally tend to not be flat for most users. And some of them are a real mix in whether somebody has flat attenuation or not. There was very weak evidence that overall attenuation was associated with sound quality. I'm showing you 4 different measures of attenuation. The first one is PAR, that overall attenuation measure. We've got the attenuation averaged at 512 and 4 kilohertz. We've got the attenuation averaged at 3, 4, and 6 kilohertz, and then the average attenuation at the extended high frequencies, 10, 11, 12.5 and 14 kilohertz. The only analysis that was statistically significant was the attenuation at 3, 4, and 6 kilohertz, and it was a weak correlation. And what that means is that there's a lot of individual variability, and so you could measure attenuation for every person, but you can't really predict if they're going to be at a 10 or at a 2 because you have people with the same achieved attenuation providing very, very different ratings of sound quality. We also looked at the difference in attenuation, at 250 hertz and 4 kilohertz endpoints and the quality rating. And again, we see this weak but statistically significant relationship where the trends were in the right direction, but you wouldn't be able to conclude for an individual person if it's going to sound good or not, because you can have two people with a 10 dB difference, and one of them says that's a 2 and one of them says that's a 10. So we thought, well, we're doing this in a lab with a song that people may or may not like. So let's do another study and see if we get stronger results by sending people out into the real world to use hearing protection products, and let's see what the data look like. So this was initiated by Amanda Duran, Connor Jansen, who's here. Azalea Coast was here last year and presented some of this data. So this was a new project using just 4 of the HPDs that I've already shown you data for. We collected, in addition, several surveys at baseline to look at their attitudes towards hearing protection. And their attitudes towards noise to understand whether their incoming opinions about sound exposure and hearing protection might be influencing their evaluations of the hearing protection products, and whether they say they're going to continue using them or not. We do 3 attenuation measurements at the first study session. So keep in mind, we're now sending people out into the world. So we don't have a measurement of what is the attenuation at the moment in time that they're using it. So we're trusting that we're training them, to put the devices in. And these are not AUD students. AUD students are specifically excluded from participating in this project. So the first time they put the earplugs in, they haven't had any training on how to put the devices in. We measure the attenuation. We train them on how to put the earplugs in. We re-measure the achieved attenuation. We repeat the training, and they put the earplugs in again. So we have 3 different measures of what attenuation they achieve with the earplugs. We sent them out into the real world with whatever pair of earplugs they were tested on in the lab. And after they have gone to at least 2 different events with loud music where they use the earplugs and provide ratings on the earplug, then they come back to the lab and they get another pair of earplugs, and we measure their attenuation with that one and send them out into the real world. So they come back to the lab up to 4 times and get 1 pair of earplugs each time. And the order that the earplugs are provided in is counterbalanced across participants. So we have equal numbers of, HPD 1 being the very first one and HPD 2 being the very first one, and so on. So 15 participants have completed all 4 HPD conditions, and there's 6 additional participants that have completed somewhere between 1 and 3 conditions. And we had, again, 2 specific hypotheses related to overall attenuation and uniformity of attenuation. So we were trying to get some separation in the parameters with these 4 earplugs. So how much attenuation did participants get with these earplugs? Again, I'm showing you the manufacturer's data, the average data, the individual data. It looks a lot like what we saw with the AUD students. So people are generally performing about the way that they did in the manufacturer's studies with the packaging. If we look at the achieved attenuation, what I want you to take out of this, number one, we've got the subset of participants who that was their very first time coming into the lab and going through the testing. Those bars are the lowest, meaning that regardless of which earplug you were getting, the people who had no training were generally getting less attenuation. The second bar in each of the plots is the rest of the participants who had already been trained with at least one other earplug. So when you look between those first two bars, you generally see more attenuation achieved in those second bars, meaning if you'd had training on a different earplug, you generally got a little bit more. One of those group differences with HPD1 was statistically significant. The others are not. They're fairly small sample sizes, and we're continuing to collect data. So we'll see how those differences hold up over time. Bars 3 and 4 are the important ones. Those are the two trained insertion measures, and that's what we're assuming people are likely to achieve when they go out into the real world and use them at events. Group analysis, again, we have not seen reliable differences when people go out into the real world and use each of these 4 different earplugs. But again, a lot of individual differences. And you can see that for every single earplug, there are outliers, meaning individual people had some pretty strong preferences within and across the earplugs.
This is Frank interrupting. Sorry, Colleen. With a quick editor's note after the fact. I'm from the future. At this point in Colleen's presentation, she played audio samples, which I provided for her. They are going to show the different attenuation and frequency response of different filtered over-the-counter musicians' earplugs, which she's referring to. First, we're going to listen to an unfiltered version of the sample. The audio is from a Beatles cover band I was performing with at the time. Let's listen.
I'll just share with you clips from the other HPDs. So this is filtered according to the manufacturer's labeling. So quieter.
The next sample is slightly louder. It's from a different earplug that doesn't offer as much attenuation. Here it goes. Sample number 3 is from an earplug that has a very even frequency response, but a little bit more attenuation. And finally, the 4th sample, slightly less balanced response, similar attenuation levels.
What did we find? We are continuing not to find compelling support, or in this case, very much support at all, for the hypotheses that we went into this study with. Looking at the personal attenuation rating, again, really, really variable results across individuals. There is a statistically significant correlation, but again, you would not be able to draw any conclusions about if this person has this much attenuation, they're going to think it sounds better or worse, on an individual level. And the uniformity is not emerging as being reliably related with this real-world data. But there are some really cool things that we have found in the real-world data. I think this is one of the things that is the most interesting to me. So first, we just have all of the data. They can go to lots of different things. We don't tell them where they have to go or how loud it has to be. They use them in their real-world exposure experiences. So we can look at all of the data. Their sound quality measurements on the survey are higher, better than they are in the open ear condition. So we're seeing that they say things sound better when they're using these earplugs than when they're not using them. And then we can break it down into individual conditions as well. So we can look just at the people who went to bars and clubs, just at the people who use them at concerts. Part of this data was collected during COVID restrictions when the entire music world was largely shut down, and so they were able to listen to music in a vehicle or on a home stereo as well, in order to meet the IRB's requirements that we not force people to go into crowded places at a time when that was seen as not very safe. And in every single condition other than concerts, we have reliable differences where the music is perceived as sounding better with earplugs than without the earplugs. I think that is hopefully going to give users some increased confidence that it's not destroying sound quality when you see real-world data that people are saying this actually sounds better. We ask them questions about their perceived risk while they're at the venues with and without the earplugs. We also ask them to use an app-based sound level meter to tell us how loud it was at the location they were using the earplugs. You can see that on average it was just about 90 dBA when they were using these. The range was somewhere 70 to 120 I have on there. Their loudness rating on a 1 to 10 scale, average was 7.6. Loudness without or with the HPD, they rated it as 5.3, so they're rating it as less loud when they're wearing the HPDs. Their self-assessed risk on a scale of 1 to 10 is 6 without the HPDs, and then 3.6 with the HPDs. So generally they're perceiving things as a little bit quieter and perceiving themselves as safer. Really big interest of ours, how likely are you to continue wearing these HPDs? These are the data for the 4 HPDs. Some of them they're very likely to continue using after the study. A number of people said, I'm likely to keep wearing HPDs, but I would want to find another brand. That's the orange section of the pie for each of these. And then there were a few people who said they were neither likely nor unlikely to wear earplugs. The yellow bars, somehow that got dropped off my legend there. Those are no, I'm not going to keep wearing earplug answers. We were interested in what are the other factors that might be related with those decisions, given that sound quality really didn't emerge as a big one. Comfort is clearly different from earplug to earplug. Again, individual differences where, the ones with the high ratings, there's a couple of people who thought they were uncomfortable. Some of the ones with the lower comfort ratings, there's individuals who are rating them as very comfortable. There is a question in the survey about whether they would recommend the earplug to others. And the data really parallel the comfort data, surprisingly, closely. And Connor has done a multiple regression analysis. He presented this data last year on a poster with some other students in the lab. And looking at the factors that are associated with recommending HPDs, comfort was the number one driver of whether they would recommend HPDs to others. Music quality did emerge in that analysis as statistically significant, and so did the achieved attenuation. So having less attenuation and more uniformity were related at a statistical level with whether you would recommend HPDs to others. Connor is doing another project right now, so come to his talk tomorrow and he'll tell you how the data change when you control for comfort and how the data change when you recruit musicians rather than people who are music listeners. So I'm going to summarize the HPD data, and then in the time that we have left, I'm going to talk to you about another data set which is related to what are audiologists doing right now to care for musicians? What are we seeing, and how does it conform? How does it follow the AAA consensus document or not? So Of the data that I've just shown you, there are recommendations for minimal HPD attenuation and uniform attenuation. Our data up to this point are not really providing scientific support. That's not to mean that we should throw out those recommendations. We don't have better recommendations other than, I would say, pay attention to comfort. We've always known it. If it's not comfortable, it's probably not going to be worn, but that really is emerging as one of the number one factors in their ratings and whether they say they'll use it and whether they'll recommend it to others. And please remember to verify achieved attenuation. Even if it turns out that neither the overall attenuation or the uniformity significantly, predict their sound quality ratings, it is still essential to understand if the person is achieving the attenuation that they want or need and that they're getting the product in order to have. The hearing tests are essential. The verification is essential. These are really important. So many of the clinicians who provide care to musicians and other performing artists don't do these things, in particular verification. And so we did a survey study. Shaban McGinnity had published data. They surveyed protocols used in the care of musicians by audiologists in Australia. And so Shaban, Heather Maliek, and one of our AUD students, Kay Eidecker, we came together and developed an updated version of Shaban's survey that was used in Australia and circulated the survey in the United States to look at what's happening in the United States by audiologists who provide care for musicians. The Australian data indicated about 30% of the people providing care for musicians had a specific protocol for the care of musicians. And of those with a protocol, there was tremendous variability in what was included in that protocol. So we really wanted to know what's happening in the United States. And we were very interested in to what extent those practices follow or don't follow what's in the AAA recommendations. So it was a survey study. Participants completed the survey online. It was really broadly advertised in the AAA electronic newsletters, State Audiology Association advertisements, social media, electronic mail messages, and Michael sent it out to everyone who was on the Gold Circle list for us. So thank you to anyone in the room who might have participated in that survey. I've got a student who is getting ready to do a new round of data collection to look at how things have changed now that we're 5 years out from the release of the consensus guidelines. There were 71 individuals who completed this. So we looked at the education. These are all people who dispense custom fit hearing products. That was the criteria for study entry was you dispense musicians earplugs, custom fit musicians earplugs. We asked people about continuing education. 76% of them had completed some sort of continuing education in either noise exposure, industrial hearing conservation. 52% of them had completed continuing education units that were specific for musicians, and I'll talk about which ones are, overlapping. Those are not discrete units. And you can see the most common sources of education. I just want to highlight NHCA as one of the number one places come for this information. Probably doesn't surprise anyone to see Sensophonics as the number one source for education on care of musicians. Percent reporting a musician-specific protocol, the way that I'm going to show the next data slides. So we have the overall participant group, regardless of whether they've had continuing education in occupational or music topics. 37% of the total participant group reported they have a specific protocol for musicians. If we look at the people who have had no hearing conservation or musician CEUs, 13% have a protocol for musicians. People who have had industrial hearing conservation but no music CEUs, same 13%. Of the people who have had musician CEUs, with or without industrial hearing conservation CEUs, 56% have a protocol for care of musicians. So higher, not huge, but higher. And then we looked at what were the most commonly reported protocol elements for each of these groups. And we focused here on case history, otoscopy, counseling, education. These were the ones that emerged as the most commonly reported. And it was very high rates across all of these groups, whether you're looking at people with no CEUs or people with all of the CEUs. Where we see differences is when we look at the audiogram and high frequencies and otoacoustic emissions. No hearing conservation or musician CEUs, 6% doing high frequencies, 38% doing an audiogram, 13% doing OAEs. That increases as you look at people who have had some industrial education, in addition to their degree. People who reported having completed musician CEUs had much, much higher rates of including the audiogram, 82%, versus the 38% overall. 54% doing extended high frequencies, 49% doing otoacoustic emissions. So we see some differences. We asked about other protocol elements, and SRT, word rec, TIMPs, acoustic reflexes, speech and noise, those generally tend to be reported at lower levels, kind of across the board. HPD verification, do you verify attenuation of custom fit musicians' HPDs? About 40% of the total group said yes, and that actually didn't vary based on CEU education. It was about 50% across the board, no matter how we broke things down. Of those who reported verification, they primarily reported using real ear attenuation at threshold with a little bit of probe mic thrown in. And then the last question we asked was about HPD validation, which is more, as opposed to real ear, using surveys to get at whether the HPDs are perceived as beneficial and whether they're being used. Again, very low rates, 35% overall. This was higher with those with the musician CEUs, 44% versus 13% in the group without, but generally not being done to a high extent, and where it is being done, it was almost universally informal discussion and not any type of systematic data collection. The retrospective survey study design, it doesn't allow us to draw conclusions about causality. We don't know if the people who have had musician CEUs started doing those procedures because of the CEUs, or if they were already providing more elements, more components in care and are seeking CEUs in order to continue to refine their education. So those are some things we're still interested in. But I think one of the major take-home messages, there are incredible opportunities to increase the use of recommended best practice protocols among audiologists who are caring for musicians. And that's why I'm delighted to see events like this at NHCA and other conferences to try and get the word out about how to take care of musicians. And hearing protection fit testing verification really is increasingly recommended for all sound-exposed populations. The military now requires this for some at-risk personnel. That was announced here last year at the NHCA conference. Just last month, NIH issued a science update that recommends fit testing, HPD verification for all workers who are enrolled in a hearing conservation program. NHCA sponsored an international symposium on this topic in summer of 23. So there's lots of information. It's increasingly recommended as a best practice, and I hope that you'll all leave here and make sure that you're doing fit testing and verifying attenuation in your patients. Thank you.
Talking Ears is a production of Earmark Hearing Conservation. The theme music is by Scott Hallam. You can find more of his music at audiodowsing.com. The show is produced and edited by Juan Vasquez, Scott Hallam, Mary Kim, and myself. Thanks for listening.